This is video number 1 for sections 1.3 and 1.4, Finding the Slope from 2 Points. This lesson is all about reviewing the concept of slope, something you've probably done before. We should start with some sort of definition for slope. I think a good one-word definition is the word steepness. The slope of a line simply refers to how steep it is. Now we want to assign a number for the slope, and we want bigger numbers to go with steeper lines and smaller numbers to go with flatter lines. Well, it turns out that to find this number, this slope number, we just need to compare two things. In particular, we need to compare the vertical change of the line, in other words, how much does it go up or down, with the horizontal change. How far does it go left or right? And if you calculate the ratio, in other words, the fraction or division problem of those two items, you come up with the slope number. You have probably seen this before using more simple words. Usually we just write down a rise over run. And so we say the slope is the ratio of the rise over the run. That calculation will tell us something about the steepness of a line. Let me see if I can illustrate this definition in this problem here. So the directions say find the slope of the line that is shown. I've given you a line. I've marked a couple of points in particular on the line. That turns out to be helpful. Well, all I need to do is pick a starting point. I'll just pick this first guy here, 0, 3. And I just need to think about how far left or right or up or down do I need to go in order to get from this first point to this second point. Well, I can draw it right on there, I think. If I'm here, clearly I'm going to have to go to the right a certain number of spaces, and then I'm going to have to go up a certain number of spaces. Right is a positive direction, up is a positive direction, so we're talking about two positive changes here. The amount of spaces that I went to the right is called the run, and the number of spaces that I went up is called the rise. To calculate the slope, I just need to determine how many spaces are in the rise and how many spaces are in the run. The rise always goes on top. Let's see, if I count that out, it looks like 1, 2, 3, 4, 5 spaces along the rise. And the run, 1, 2, 3, 4 spaces to the right. That means my slope is the fraction 5/4. We say that's the slope of this line. Now, what's the connection to steepness? Well, 5/4 is a number that's just a little bit bigger than 1, right? It's 1 1/4. Well, it turns out that lines that have a slope of 1 are kind of middle of the road when it comes to steepness. They're not really very steep. They're not really very flat. If a line has a slope bigger than 1, it's going to be on the steeper side. If a line has a slope smaller than 1, it's going to be on the flatter side. Well, 5/4 is just a little bit bigger than 1, and so we might say this line is just a little bit steep. If I had ended up with a slope of, say, 10 1/4, a really, really big number, we'd be talking about a very steep line. We can use this last example to come up with a more direct formula for calculating the slope. Think with me for a minute about where this 5 and 4 actually came from in this picture. Why did the rise turn out to be 5? Well, rise is a y issue. And if you look at the starting y, it was 3. If you look at the second y, the last y, it was an 8. The reason the rise was 5 is that 8 take away 3 is 5. It's just the difference between those two values. In a similar way, if you look at the run numbers, the run has to do with x. Well, the first x was a 0. The second x was a 4. If you subtract those two numbers, 4 take away 0, you get 4. Well, let's put that together into a little formula. We usually use the letter m to represent slope. We know that the slope is a ratio It's always rise over run. What we've just said is, look, to calculate the rise, just take your second y and subtract your first y. To calculate the run, take your second x and subtract your first x. These are not exponents that I've just written down. These little 1's and 2's are called subscripts. They're just keeping track of, oh, the second y or the first y, etc. Now that we have this formula, we can calculate the slope without even looking at a picture. Let's take a look at this next example. It says find the slope of the line that goes through these 2 points. There's no picture. I don't even need a picture. As long as I can identify my first x and my first y and second x and second y, I'll be all set. One of the great things too is it doesn't matter which of these you call your first point and which you call your second point. You'll get the same answer whichever way you go. Now, just to keep things simple, since this one is written first, I think I'll think of it as my first point, which makes this my first x and this my first y, right? It's always x comma y. And then this will be my second x followed by my second y. Well, I just need to plug those 4 numbers into my slope formula. Let's do that. M, the slope, is equal to the second y, that would be 3, minus the first y would be 5. And then my second x on the bottom is negative 4, minus my first x. Now be careful here, that's a negative 5. This symbol is the subtract from the formula, so subtract negative 5, and I put the parentheses just to make it look nicer. All I did again, second y minus first y over second x minus first x. Let's work out those calculations. On the top, let's see, 3 take away 5 is negative 2. On the bottom, when I subtract a negative, those guys plus out. Looks like I end up with positive 1. And so my rise over run ratio this time is negative 2 divided by 1. Now you are always expected to simplify your final slope answer. We didn't really need to do that in the last example, but if you can reduce or if you can divide evenly, then you go ahead and do that. Well, negative 2 divided by 1 has a nice answer, and so my final answer to this problem would be the slope is negative 2. Let me ask you a couple of follow-up questions now that we have our answer. The first one is, what does it mean for a line to have a negative slope? What bearing does that have on the picture? Well, let me see if I can draw you a quick sketch here. So this is just a very quick, simple sketch. I made myself an XY plane. I marked on our first point, negative 5, comma 5, right here. And then I marked our second point, negative 4, comma 3. Let's go ahead and connect those dots with a line. And then let's draw in the rise and run information. Remember, this was my first point, negative 5, 5. Well, clearly, to get from there to the second point, I would have to travel down. And down is a negative direction. Then I would travel to the right. Well, right is a positive direction. So my rise would be negative, my run would be positive. Well, when you divide a negative by a positive, you're going to get a negative number. Why did this happen? Well, essentially this is going to happen anytime you have a line like this green one that goes downward from left to right. If the line goes down from left to right, you're going to have a negative slope. If you look back up at that earlier example, the line went upward from left to right, and that's why we got a positive slope. The second follow-up question I have is, what if I asked you to compare the 2 lines that we've looked at? And specifically, what if I asked you which one is steeper? Now, maybe you can tell that from the picture, maybe not. I don't know that this picture is perfectly accurate. The point is, you don't have to look at the picture to know, because it all boils down to the slope. Let's recall what our other slope was. So our other line had a slope of 5/4. all I need to do is compare the values, just the values. You can ignore the negatives and positives. Remember, that just tells you whether the line goes up or down. The value part of this slope was a 2. The value part of this slope was a 5/4. Well, 2 is bigger than 5/4. And so therefore I know that this second line, the one we just did, this one right here is the steeper line. Whichever line has the bigger slope value, that's the one that's going to be steeper. All it takes is 2 points and you can calculate the slope of any line.